Assalamualaikum warahmatullahi wabarakatuh and good afternoon to all. Okay, so program Lepton and Meka pada hari ini adalah untuk membincangkan chapter 3 which is momentum and impulse. Okay, so let's look at to the content that you must know in this chapter. Okay, the first thing is about the momentum. Okay, so the equation for momentum, P is equal to mass times the velocity. Okay, the second one is about the impulse. Okay, the equation for impulse, J is equal to force times the time interval. Okay, the third one is also about impulse, but impulse also can be obtained from the shaded area under the force against time graph. Okay, and then the fourth one is the relation between impulse and momentum, which is they can be related with impulse momentum theorem, which is the equation represented by J is equal to change of momentum, also equal to the mass times the final velocity minus the mass times the initial velocity. Okay, next is about the conservation of linear momentum. Okay, conservation of linear momentum states that in a closed system, okay, the total initial momentum will be equal to the total final momentum. Okay, and the last part in this chapter is about the elastic and inelastic collision. Okay, so the condition for elastic collisions are, okay, the first one is total momentum is conserved and total kinetic energy also conserved in elastic collision. Okay, but for inelastic collision, okay, total momentum is conserved, but the total kinetic energy is not conserved. Okay, so let's start with question number 1. Okay. Jennifer, who has a mass of 50 kg, is riding at 35 meters per second in her red sports car when she must suddenly slam on the brakes to avoid hitting a deer crossing the road. She strikes the airbag that brings her body to a stop in 0.5 seconds. Okay, what is the average force does the seatbelt exert on her? Okay, so firstly, we have to analyze the information given. Okay, macam biasa, sila keluarkan dulu information yang diberi daripada soalan. Okay, firstly, we have a mass of Jennifer is equal to 50 kilograms. Okay, Jennifer is riding at 35 meters per second, so that means it indicates it's her initial velocity. Okay, which is U equal to 35 meters per second. Okay, then after she applies the brakes, okay, that brings her body to a stop. Okay, so from here, we know that the final velocity of Jennifer is equal to 0 meters per second. Okay, in 0.5 seconds. So that is the time interval. So delta T is 0.5 seconds. Okay, first question, it asks for the average force. Okay, so we are going to find F. Okay, so now based on the information given, okay, kita kena pilih lah. We have to choose the appropriate concept and equation that we must use here. Okay, so from the information given, we can use the impulse momentum theorem here. Okay, so from impulse momentum theorem, which is J is equal to the change in momentum, okay, which is J from the equation of force times the time interval equal to mv minus mu. Okay, so now substitute the value. F is the quantity that we're going to find. Okay, delta T here is 0.5. Okay, M mass of Jennifer is 50. Final velocity should be 0. Okay, minus 50 times the initial velocity is 35. Okay, so by substituting and calculating using your calculator now, so you will get the value of the average force will be equal to negative 3,500 newtons. Okay, which is the negative sign of force indicates that, okay, this negative sign indicates that direction of force exerted by the seat belt to Jennifer is acting oppositely. Okay, look at to second question B. Okay, if Jennifer had not been wearing her seatbelt, okay, and not had an airbag, then the windshield would have stopped her head in 0.002 seconds. Okay, what average force would the windscreen had exerted on her? Okay, so now bila dia tak pakai seatbelt, okay, so the time interval kat sini, time of collision tu dah berkurang, which is delta T is equal to 0.002 second. So we have to find the new force. Okay, so now for B, we also can use the same concept, okay, by using the impulse momentum theorem. So F, now our delta T is equal to 0.002. Okay, mass is remain constant. The final velocity also 0 minus the initial velocity, mass 50 times the initial velocity is 35. Okay, so the new average force that exerted by the seatbelt, by the windscreen. Okay, sekarang dia tak pakai seatbelt, so dia akan terhantuk dekat cermin kereta. So force exerted by the windscreen on her head, on Jennifer head, will be equal to negative 875,000 newtons. Okay, besar ni. So this is the negative, also indicates the direction of force acting oppositely. Okay, so that's why nampak tak kesan bila pakai seatbelt dengan tak pakai seatbelt. Okay, so that's it for our first question. Question number 2. Okay, so this is about the graph of force against time. Okay, given a force acting on an object of mass 2 kilograms varies with time t in the way as shown in figure below. Okay, so the velocity of the object is 4 meter per second before the application of the force. Okay, so determine the velocity of the object after applying the force for 0.2 seconds. Okay, so as usual, okay, we list out the information. Firstly, we have the mass. Okay, mass is equal to 2 kilograms. And the velocity of the object 4.0 meter per second is the before the application of force. So that means it is the initial velocity. Okay, so U is equal to 4 meter per second. Okay, then determine the final velocity. Okay, so from this question, we are going to find V and also given the time. Okay, so change of time interval here is 0.2 seconds. Okay, so from here, okay, in order to use the impulse momentum theorem, okay, we have to know the impulse, right? Okay, so since dia dah bagi kita graph of force against time, okay, macam yang saya dah explain awal-awal tadi, okay, impulse also can be obtained. Kalau daripada graph, kita boleh dapat impulse from the area under the graph. Okay, so kita boleh dapatkan impulse through the area under the graph. So this is the triangle. Okay, so kita akan guna, so impulse. Okay, firstly kita tulis dulu dia punya konsep kat sini. Concept that is impulse can be obtained from area under the graph. under F the graph. Okay, so it is half, cari area for triangle times height times width kan. So the height will be 100, okay, times 0.2. So impulse will be equal to 10 Newton second. Okay. Alright, so next, bila dah ada impulse, barulah kita boleh pakai guna impulse momentum theorem, which is J is equal to change of momentum. Macam kita guna dekat soalan yang pertama tadi. Okay, so since sekarang ni J kita dah tahu, which is value for impulse is 10 Newton second. Okay, change of momentum will be equal to mv minus mu. Okay, kita nak cari V. So mass kita dah tahu, which is 2 kilograms. V nak cari, okay, minus mass times the initial velocity is 4. So for the left hand side will be equal to 10. So kita akan dapatlah value of final velocity will be equal to, okay, tekan calculator, you will get the answer 9.0 meter per second. Okay, so this is the answer for final velocity. Okay, next is question number 3. Question that is related with collision in one dimension. Okay, so we have a 150 gram marble P, okay, with speed of 8 meter per second collides head on with 120 gram marble Q with a speed 5 meter per second in the opposite direction. Okay, so kita kena analyze question ni betul-betul. Okay, hati-hati. After the collision, marble P move in the same direction with speed 2 meter per second. Okay, first question, determine the velocity of marble Q after the collision. Okay, so okay, let's sketch the diagram first. We have marble P, okay, moving, and also marble Q. This is marble Q moving with opposite direction. Okay, so direction of Q will be opposite with the direction of marble P. So sambil-sambil tu kita keluarkan dulu information dia. Mass of P, okay, 150 grams. Okay, but the SI unit for mass should be in kilogram. So you have to convert the unit from gram to kilogram. So kalau kita tukar, it also equal to 0.15 kilogram. Okay, so kita daripada gram to kilogram, we have to divide by 1000, right? Okay, mass of Q, 120 grams also equal to 0.12 kilogram. Okay, initial velocity of marble P, it is UP, okay, equal to 8 meter per second. Okay, while the initial velocity of marble Q is, okay, tengok dekat soalan tu dia cakap marble Q move in opposite direction. Okay, so initial velocity of marble Q should be in negative sign. Okay, kena letak negatif ni. So it is negative 5 meter per second. Okay, so this is before collision. After collision, it say that the marble P moving in the same direction with speed 2 meter per second. So that means this is the final velocity of marble P. So this is VP. So sekarang ni kita nak cari VQ. Okay, So by using, okay, this is a collision, right? So for the collision, we can apply the conservation of linear momentum. Okay, so for the conservation of linear momentum, which is total initial momentum is equal to the total final momentum. Okay, in a closed system, we must assume that this is a closed system. Okay, so we have P UP, okay, plus Q UQ equal to P VP plus MQVQ. Okay, so yang kita nak cari adalah final velocity of marble Q. So by substituting all values yang dah diberi dalam soalan, so we have mass P, mass of marble P is 0.15. Okay, UP is 8 meter per second. Okay, marble Q 0.12. Initial velocity of marble Q is -5. Okay, that is a negative sign. Plays the important rules here. Kalau salah, awak identify, so your substitution will be affected and your answer pun akan salah. Okay, so continue substitute value at mass of marble P 0.15. Final velocity of marble P is 2 meter per second. Okay, 0.12 times VQ. Okay, so finally, okay, since all values dah ada, tinggal VQ je kat situ, so we'll find the final velocity of marble Q will be equal to 2.5 meter per second. Okay, so from this answer, okay, we notice that the sign for final velocity is positive, right? So it means marble Q also moving in the same direction, in positive direction lah. Okay, which is inilah arah marble Q. Okay, so this is VQ. Okay, next question. It asks whether the collision is elastic or inelastic. Okay, so the only way to know either the collision is elastic or inelastic, okay, pelanggaran kenyal atau tak kenyal hanya dibezakan dengan conservation of kinetic energy, kan? So we have to calculate the total kinetic energy initial and total kinetic energy final. Either it is equal or not. Okay, so this is for B. Okay, let's calculate the initial kinetic energy first. So total kinetic energy initial will be equal to equation for kinetic energy, it is half mv squared, right? So here, okay, will be equal to mp up squared plus half mq uq squared. Okay, so substitute the value, half mass of marble P 0.15. Okay, up is 8 squared plus half mass of marble Q 0.12. Initial velocity of marble Q is 5 squared. Okay, can be substitute with negative or positive because kinetic energy is a scalar quantity. Okay, so tak kisah sebenarnya nak substitute dengan negatif pun boleh kalau you substitute with negative. So since we have squared the velocity, so the value still positive. Okay, so for initial kinetic energy, calculate ni kita akan dapat 6.3 joule. Okay, and then we have to calculate the final kinetic energy, okay, which is half mp VP squared plus half MQ VQ squared. Mass of marble P 0.15. Final velocity of object P is 2 meter per second squared. Okay, plus half mass of marble Q 0.12 times the final velocity of marble Q. Just now we calculate in previous question, 2.5 squared. Okay, calculate and we will get the total final kinetic energy will be equal to 0.675 joule, isn't it? Okay, and from here we can see that, okay, kita boleh tengok value of kinetic energy initial dengan final sama ke tidak. For initial we have 6.3 joule. For final kinetic energy it is equal to 0.675 joule. So tak sama lah kan? So we can conclude that the total kinetic energy initial is not equal to the total kinetic energy final. So kalau tak sama, which is kinetic energy is not conserved, so it means this is inelastic collision, right? Okay, now we continue with our last question, question number 4, which is related about the collision in 2 dimensions. Okay, so we have a 7,500 kilogram truck traveling at 5 meter per second east. Okay, so dia dah bagi arah truck yang bergerak ke arah timur dengan 5 meter per second collides with a 1,500 kilogram car moving at 20 meter per second in a direction 30 degrees south of west. Okay, so dah ada diagram yang diberi, so dah memudahkan kita punya process of analyze. Okay, after collision, the two vehicles remain tangled together. Okay, so they stick together lah. Okay, with what speed and in what direction does the breakage begin to move? Okay, so the question asks to find this final velocity. Okay, final the speed and direction. So we have to find the final velocity of the breakage after the collision. Okay, so from this diagram, okay, dah ada diagram kat sini. Truck moving to the east, which is moving horizontally. Okay, but car moving with an angle. Okay, so this car has the initial velocity in x and y direction. Okay, we can resolve the initial velocity of the car as uy and also ux. That's why this is called as the collision in 2 dimension. Okay, so kalau tak clear, we can redraw the diagram. Okay, so this is the truck moving horizontally. So it means the truck has only the initial horizontal velocity. Okay, so kita kena label with clearly. Okay, so this is as x component, 5 meter per second for the truck. Okay, and this is the mass of truck is equal to 7,500 kilograms. Okay, then the car, okay, the car has the initial velocity. Okay, so kita fikir secara Cartesian lah, on Cartesian plane lagi mudah untuk kita resolve. Okay, so this is direction of u car. Angle dia kat sini, 30 degrees. Okay, so from here we can resolve lah untuk ux and also uy. Okay, so after the collision, they are stick together. Okay, lepas berlanggar ni, mereka stick together. Tapi kita tak tahu arah mana. Okay, we have to find the final velocity dia. Okay, so for this collision, okay, here we are going to use the concept of principle of conservation of linear momentum. Okay. Okay, UK tadi kita tahu given 20 meter per second. 20 meter per second. So, for conservation of linear momentum, nak guna conservation of linear momentum pun, we have to split into X component and Y component. Okay, so kita akan buat separately. Okay, total momentum initial in X equal to total momentum final in X. So instead of using the general equation M1U1, so we can split. This one is M truck U truck X, okay, plus M car U car in X component, okay, equal to M truck, since it is stick together, so kita boleh terus tambah lah mass car, okay, but here represent V X, okay. So substitute the value. Mass of truck just now 7,500 kilograms, okay. U truck is equal to 5 meter per second, plus mass of car just now is 1,500. Okay. Kat sini kita keluarkan lagi. Mass of car is 1,500 kilograms. Okay. So 1,500. Okay. U car in X component, it is in quadrant 3 kan. So bila dalam quadrant 3 in horizontal, in X component dia adalah negatif. So we have to resolve carefully lah, dengan betul. Okay, we have to resolve correctly. So it is negative 20 cos 30 degrees. Okay, equal to mass of truck 7,500 plus 1,500 Vx. Okay. So from here we will get our V final velocity in X component, which is equal to, okay, tekan calculator, kita akan dapat berapa? (1.28 meter per second). Okay, so that is for X component. Tak habis lagi, kita kena selesaikan juga untuk Y component. Okay, so for Y component, okay, total momentum initial in Y equal to total final momentum for Y component. So the equation will become M truck U truck in Y, okay, plus M car, mass of car, U car in Y component equal to M truck plus M car times the final velocity in Y. Okay, then substitute the value. Mass of truck is 7,500. U truck in Y component ada value tak? Tak ada, kosong, because the truck is moving horizontally. So the initial velocity in Y component for truck will be equal to 0. Okay, so plus mass car 1,500. Okay, for U car also equal to negative for y component because it is in quadrant 3. Okay, y component dia adalah bahagian bawah. So that's why it is negative 20 sin 30 degrees. Okay, equal to Mestra 7500 tambah 1500 Vy. Okay, and finally we will get our Vy is equal to, okay, tekan calculator, we will get negative 1.67 meter per second. Okay, so now kita dah ada final velocity in x component and final velocity in y component. Apa yang perlu kita buat? Okay, we have to find v. So by using equation ni lah, resolving resultant vector vx squared plus vy squared square root. Okay, so substitute the value. Vx just now 1.28 squared plus negative 1.67 squared. So the magnitude for the final velocity will be equal to 2.10 meter per second. Okay, so this is the speed. Tak habis lagi, kita perlu cari direction. Okay, so in order to find direction, we will use tangent theta equal to Vy over Vx. Vy is negative 1.67 divided by 1.28. So theta will be equal to negative 52.53 degrees. Okay, so negative sign here, it indicates dekat mana, where is the direction of final velocity. So since kat sini Vy kita adalah negative, so it means it is in negative y direction. But for our x is positive, so maksudnya kat sini. Okay, so this is the theta. And this is the final velocity of the truck and car. Okay, or the direction you also can write it as, okay, theta is equal to 52.53 degrees below positive x-axis. Okay, so this will be our final answer for direction of the truck and car. Okay, finish for question number 4.